Hey guys, welcome back. Today we're going to talk about solving multi-step equations. Last year you learned how to solve one-step equations and two-step equations, and this year we're going to actually add on combining our like terms and distributing and solving multi-step equations. So we came up with an acronym that we use as a checklist when solving equations, and what it is DCMAM, D-C-M-A-M. And what that means is the first thing you're going to do when you get an equation is actually, if you need to, you're going to distribute. Okay. The second step will be to combine like terms. Okay, and this is important. So we're only going to combine like terms on either side of the equal sign. So you're never going to cross the equal sign at this point. So either side of the equal. Okay. And the third step is going to be to move the variable. So we want to move the variable to one side. We only want one occurrence of the variable. So we're going to move one variable to one side. Then we are going to add. A is for add or subtract constant. And then our final step will be to multiply or divide by the coefficient. Okay, so we're actually multiplying or dividing by the coefficient. All right, so remember golden rule of algebra. This is important, okay? The equal sign. Okay, whatever you do to one side of the equal sign, you must do the same thing to the other side of the equal sign. So you need to keep it balanced. So our first example, we'll look at number 1. We can't distribute. We can't combine any like terms because, remember, we can't cross the equal sign. So we can move the variable. So I'm going to take this 8b, and I want to move it to the left side. Now, in order to do that, in order for 8b to go away, per se, I'm going to actually subtract it. So if this is positive, then we would subtract 8b, or think positive and a negative. Now, whatever we do to one side of the equation, we have to do to the other. Now, notice I'm lining my b's right up with each other, because I'm just going to look at the coefficient, and 10b minus 8b would be 2b. My 18 is going to come straight down. That's my constant. And in this case, the additive inverse says that if you add the opposite, you're going to get 0. So they cancel out, and what we're left with is just 4. Okay, so now we want to add or subtract a constant, and we're going to move the constant to the other side. So we're going to take negative 18, because we have a positive here, so we're going to do the negative. 18 minus 18 is 0. So 4 minus 18 is negative 14. I'm going to keep my equal sign there, and my 2b is going to come down. So now I've got 2b is equal to negative 14, and I'm going to divide those sides by 2. So my final answer is b is equal to negative 7. Okay. Now, what's really nice about solving multi-step equations is once you get your answer, you can do the check step. And this is really important. Your check step, you take your answer and you plug it back into the original equation. So 10 times now, instead of having a b, we're saying b is negative 7 plus 18. Does that equal 8 times negative 7 plus 4? So by doing the check step, we end up with negative 70 following order of operations is equal to negative 56 plus 4. So when we do it, we get a negative 52, and that's going to also equal a negative 52. Does that work? Yes, it does. So the check step is great for solving, checking your answer. But your answer is actually b is equal to negative 7. Don't make a mistake and think that it's equal to negative 52. That's just used to help you in the process. So this video is going to go pretty fast through each of the examples. I'm going to ask that you pause it at different times and try one on your own, and then go back and look to see if you got the same answer. But I am going to go pretty fast. So I'm going to think of my acronym DCMAM. Okay, I can't distribute anything. I don't have any parentheses, but I can combine my like terms. Okay, because I'm combining on either side of the equation, I've got a 2x and I've got a negative 5x on the right side of the equation. On the left side of the equation, I can't do anything, so that's going to stay the same. The 2x minus 5x is negative 3x plus 8. Okay, so now I want to move my variable, and I'm going to move my variable to the other side, and I'm going to do that if I've got it. I like my variables to be on the left, but it's a preference. I'm going to add 3x to both sides, because negative 3x and positive 3x will be 0x, so that will get it moved over. Additive inverse will cancel that out, so we're left with 6x, because 3 plus 3 is 6, minus 4 is equal to 8. All right, so now I want to add or subtract a constant. I want the constant to go to the opposite side of the variable. So I am going to add 4 to both sides because I'm looking at this opposite. I've got -4 and I've got a +4. They will cancel out, and I'm left with 6x equals 12. My last step is to multiply, or in this case, divide by the coefficient. So my x is equal to 2. Okay, again, you can go back in and do your check step, okay? And if you did your check step, you'd find that 3 times 2 minus 4 is equal to 2 times 2 plus 8 minus 5 times 2. This is 6 minus 4 on this side, and this would be 4 plus 8 minus 10. So on this side, 6 minus 4, I get a -2. And on this side, I've got 12 minus 10. This would be a +2, I'm sorry. Whoops, +2. And this would be 12 minus 10. So we end up with 2 equals 2. So that would work. So I'm not going to continue to do the check steps in all of the examples, but I would expect that you would always go back and do your check step. Another way to do the check step, and this is actually really kind of nice, is to actually do it on Desmos. I'm going to do a separate little video lesson on doing that after we complete this lesson. So moving on to the third example. Okay, we've got, in this case, we have 40 plus 14j. We do my little checklist for DC Man. Let me get a little darker color here. All right, let's see. The pen's not working right. Okay, nope, that's not cooperating. Let's try it again. Okay, we've got DC Man. So in this case, we can distribute first. So 40 plus 14j is equal to -8j minus 26. Again, I'm just distributing. Okay, I'm going to combine like terms. Well, I can't combine anything on either side of the equation. So the next step is to move the variable. I'm going to move my 8j to the other side. I'm going to do that by adding 8j. And notice I'm going to line it right up underneath the j on the other side. So I end up with 40 plus 22j is equal to -26. It will cancel out. Now I'm going to add or subtract my constant. I'm going to subtract 40. So I end up with 22j is equal to -66. And then my final step is to divide both sides by 22. My j is going to be equal to -3. Okay, so moving on to number 4. I'm going to start by distributing. 2x minus 5x minus 5 is equal to 3x plus 1. I'm going to combine my like terms. On the left side of the equation, I end up with -3x minus 5 is equal to 3x plus 1. When I bring the 3x to the other side by subtracting the 3x and doing the opposite, I end up with -6x minus 5 equals 1. And when I add 5 to both sides, I'll get -6x is equal to 6. And then I can divide by my -6, and x is going to be equal to -1. Okay, again, pause the video and try some of the problems. Number 5, I'm going to distribute 15x minus 6 plus 4x. So all I did was distribute right there, and that's going to equal 9x plus 6 minus 2x. I'm going to combine my like terms, so I'll get 19x minus 6 is equal to 9x. Oops, I forgot to add my like terms on this side. So this side of the equation, I've got a 9x minus 2x, so I'll have 7x plus 6. Okay, when I subtract my 7x from both sides, I end up with 12x minus 6 is equal to 6. And then when I add 6 to both sides, I get 12x is equal to 12. Final step is dividing by 12. My x for number 5 should be equal to 1. Okay, so moving on to number 6. Now this is a little different. I just have 27 on the left. That's fine. I'm going to distribute. I get -18 and I have a +16. So I distributed that -3. I am then going to combine my like terms on the right side. So I got 9c minus 18. So I combined 3c and 6c. And then I'm going to bring the 18 to the other side. So in this case, my variable is on the right. That's fine. So I end up with 45 equals 9c. So when I divide both sides by 9, I end up with 5 is equal to c, or we can say c equals 5. Okay, so that is number 6. Number 7. Okay, when I distribute, I've got a -12x minus 9 plus 24x plus 4 is going to be equal to 43. I'm going to combine my like terms. When I do that, I get 12x, and I've got my negative 9 and positive 4, so it's 12x minus 5 is going to be equal to, I forgot the 43. Okay, when I bring then add the constant to both sides, so my 12x is going to be equal to 48, and when I divide by 12, my x is going to be equal to 4. Okay, moving on to number 8, 3n minus 5 is equal to negative 48 minus 40n. I'm going to add the 40n to both sides, so right now I'm just moving my variable. I end up with 43n minus 5 is equal to negative 48. I'm going to add 5 to both sides. 43n is going to be equal to negative 43. So then, let's see, make sure I've got this. Yep. Now I'm going to divide both sides by 43. And when I do that, my n is equal to negative 1. And then my final example for this side, number 9, I distribute negative 20x plus 10 is equal to negative 6 plus 12x. I'm going to add my 12x to both sides. I can't distribute or combine any like terms. So I did make one little mistake here. This should actually be a minus. So this is minus. So it's negative 6 minus 12x that I distributed. Okay. They cancel out, and I'm left with, in this case, negative 8x plus 10 is equal to negative 6. And then I would subtract my 10 from both sides. Negative 8x would be negative 16. And then when I divide by negative 8, my x is equal to 2. Okay, so these examples, all 9 of them were examples of just having one solution. Now, that's not always the case. Okay, when you solve an equation and you get a true statement, the solution is actually all real numbers, okay? Meaning that any number would work, okay? We write that with a special symbol. It looks like an R, but it has a double stem like that, so that's all real numbers. And if you solve an equation and you get a false statement, it's actually, the solution is no solution. So there's no possible number that would make that work. And let me show you an example of each. So in number 10, if I distributed, again, I follow DC MAM. Okay, so first I distribute. I've got 12y plus 6 is equal to 12y plus 6. Okay, I can't combine any like terms on either side of the equation, but I can move the variable to the other side. And watch what happens. When I subtract 12y from both sides, it cancels out on both sides, and I'm left with 6 equals 6. Well, that is a true statement. Because it is a true statement, my solution would be all real numbers. Okay? Now, that's a little bit different than number 11. When I distribute number 11, 5 times 1 is 5. I get 5 plus 20m is going to be equal to 6 plus 20m. So I distributed those. I can't combine my like terms. But when I move my variable by subtracting 20m from both sides, I end up have the 20m's cancel out on both sides, and I'm left with the two constants, 5 equals 6. Well, that's a false statement. Last time I checked, 5 did not equal 6. So that means there is no solution. There's no number that would make that work. So it's no solution. Okay. So the last little example we have here is number 12 on this section. I want you to try it on your own and then see if you come up with either one solution, all real numbers, or no solution. When you distribute it, you're going to get 6x plus 42 equals 6x plus 84. Okay, so when you subtract your 6x from both sides, you're left with 42 is equal to 84. And that's a false statement. So again, that would be no solution. All right, so I'm going to continue. This video will only work for the first 15 minutes. So the section of proportions in the calculator, I'm going to do the second video, so please be sure to watch it.